What's up, guys? Christopher Sweat here. If you're tuning in through a rant, then you already know who I am. But if you're joining us from Dr. Brian Keating's channel, you may have saw the old episode that Keating hosted me on like a year and a half ago, maybe 2 years ago, called Philosophizing in Public. Dr. Brian Keating is a good friend of mine and also has labeled me as a street philosopher, or some might say public intellectual. But beyond that, I thought it would be super interesting to talk to Brian Keating. And actually, in case you didn't know, he runs a physics department at UC San Diego. So he's very connected to Physicist, the broader physics community around the world. But I wanted to talk to him about some of the more basic concepts in physics and the pressing issues in physics. You'll love his content. It's possible you already saw him on Lex Fridman or Joe Rogan, so you should definitely check it out. But I know it can be a little bit overwhelming if you're hearing the kind of academic, scientific physics discourse for the first time. So I think this episode is actually a great way to kind of get an introduction to physics. We get to talk about cosmology, which is where Brian specializes, experimental physics, and we even touch on the Israel-Gaza conflict and the implications on university campuses. Anyways, hope you enjoy this and meet my friend, Dr. Brian Keating.
All right, we're live. Okay, Dr. Keating, I was at this event in the Bay Area like a couple months ago, and some people were talking about like some random physics guy that was on Joe Rogan. You were on Joe Rogan like what, in September or August of this year?
Yeah, I got on in August. I ended up making the trek to Austin in the middle of a hurricane here in San Diego, but survived and had a good time with Joe and Jamie and the whole crew out there. It's quite an operation, which I assume you'll be at someday. You'll be exceeding. You'll say, Joe Rogan used to be the Christopher Sweat of podcasts.
Yeah, that would be cool. What was it like there anyway? I mean, you see like the YouTube videos, but I'm sure it's like different when you're like on the mic.
I did a blog post on my blog at briankeating.com, which all your viewers, listeners should go to, because I give away these meteorites, which I gave to Joe. I gave Joe a meteorite. I give them away to different folks throughout the month. And when after I came back, I said, well, how many people? I was only the 2023rd episode. That was pretty cool. So a lot more people are interested. And since then, I got a lot of questions. Can you connect me to Joe? Can I go on? I've got a book coming out. And the answer, unfortunately, is always no. Just he does all his own booking. He reaches out. He'll get in touch with you if he wants to talk to you, basically. So he got in touch with me, invited me on, and partially that was, I think, because I'd been on Jordan Peterson, on his podcast, and I'd been on Lex Fridman, and they're all very close. And so I got invited. So, but because people are so curious, I wrote a blog post. You can find it. What's it like to be a guest on the Joe Rogan Experience? And I kind of go through it and take a reader or viewer on it throughout the whole experience.
Yeah, that's really cool, actually. Just like for any of my readers or listeners that are tuning in, Dr. Brian Keating hosts like a really epic, we'll call it physics podcast. But I mean, it seems like a lot of your guests are sometimes in different parts of the hard sciences, mathematics and biology, philosophy. Yep.
I've had on a young, modern day street philosopher named Christopher Sweat.
Yeah, thank you.
He has been on. You can find that in the back catalog. That was a great convo.
It is. I think it was called Philosophizing in Public.
That's right. Exactly.
Actually, I want to ask you like some physics questions, but my base of knowledge isn't in physics. You're the expert, and so are many of your friends and colleagues. Yeah. But so like I was taking some history of science classes, which was pretty much like philosophy from a number of physicists. And we got into the topic of cosmology, and I thought cosmology was super interesting because to me, it's like another way to describe space. And I have a very spatial orientation, even when I'm thinking about networks or computer systems. But like, so I notice you're pegged as a cosmologist. What does that mean, and how does that relate to physics?
So so basically it's confusing because it sounds like cosmetology, which I also do. You can tell from the hair, the nails, and the makeup. I'm a summer. But the the relationship is because the word cosmos, the prefix cosmos, means beautiful or appearance. And it really is indicative of the fact the universe is a beautiful place. It presents itself to us, and we can only glean from it what it wants to show to us. Like much like the ladies in our lives, right? They're kind of mysterious, and to get it to reveal things is not like any other science. Even it's not like astronomy. So cosmology is a branch of astrophysics. Astrophysics are the laws of physics applied to astronomical settings. So stars, galaxies, planets, even astrobiology, life in the universe can be subsumed within that. And then cosmology is the study of the governing principles of the universe as a whole. And so I always point out that, you know, when people say that astronomy is hard because we actually cannot do an experiment in astronomy. We cannot take, you know, this meteorite, which I will provide to your listeners, briankeating.com, and I can't expose it to an extra billion years of the solar wind to see, you know, if that impacts the isotope ratio, or if that would impact an amino acid that's trapped somehow inside of this beautiful, you know, shard of the early solar system or the pre-solar system. So I can't do any of that. And so, but cosmology is even harder because there's literally billions of meteorites, and you know, I wouldn't give them away if there weren't so many of them, and you know, they cost a little bit to get, but that's fine. But I wouldn't, you know, certainly they come to us, but they're one of the few things that even comes into the Earth besides photons, some particles called neutrinos, and you know, basically that's it. Solar wind and so forth. They're very, very rare examples where you actually have something of either energy or matter or both to study in your laboratory. Everything else has to be reached to you by, but think about it, Chris, the universe is the only thing. The uni means one. So there's only one universe. There might be, you know, 8 planets in our solar system, and, you know, tens of thousands of asteroids, and there might be 100 billion stars in our galaxy. And we think there are over 2 trillion galaxies in the observable universe. At least you can do statistics and see how many of them are red, how many of them have spirals, how many of them have nebulae, how many of them could have life, how many of the exosolar planets have my colleagues discovered with the Kepler satellite that are in the Goldilocks zone, where you can have liquid water and you can have potential for habitable worlds to exist. And yet there's only, you know, say 5,000 or 6,000 of those, but still you can do observations on a multiplicity of those. Universe, only have one, makes cosmology extremely hard.
God, that's so fascinating. Okay. And then also, I mean, there, you know, there's all these schools of thoughts that have emerged. Let's even just say like Newton to today. But so like, why is it impossible to have a conversation about physics without God at some point?
Oh, that's, yeah. Yeah. That's another okay. Question. I'll ask you this, like, what's your favorite day on the calendar? Every year, it comes up every year. What's your favorite day?
My birthday.
Yeah, exactly. That's I usually ask that to people. The only person who's ever given me an out of the ballpark answer was Ben Shapiro. I had Ben Shapiro on my podcast a couple times. Actually, just saw him when I was in Florida about a week.
He's a contrarian.
He is a contrarian. Yeah, he's built himself a real empire, and I've got incredible respect for him. He, like I am, I'm Jewish, and we practice Judaism. He's much more, you know, strict and observant than I am, but he's like a celebrity. I'm walking around Miami with him. And everybody's you know, take a selfie, do this. Even if they don't like him, they want to meet him because he's not only the most famous Jew on the planet, but he's the most famous conservative. And, you know, like it or not, I mean, he has on people that disagree with him all the time. And anyway, I don't want to dig into that. But I asked Ben Shapiro when he was on, and he said Yom Kippur. And I was like, all right, Ben, you know, let me see if I can work that into my theory. But my theory is that the reason your birthday is so important to you is because it's a singular event before which you could not have had personal knowledge of the conditions of the universe that marked your entry into the universe as a coherent being, right? Forget about reincarnation. I'm not going to get into all that stuff. But so too does mankind as a collective, as an ensemble of literally 100 billion souls, just like you and me, infinitely valuable in my opinion, although some more valuable than others. You know, some of the a-holes that have lived throughout society. But anyway, ignoring that, so we look at that and we say the 100 billion people have lived. Each one of them had an origin point at some point, and they're curious about what came before. And humanity as a whole is curious about what, or if there was a universe before our universe came to be. And in fact, Chris, if you wrote the year on a ping pong ball, you had 2024 ping pong balls, sure, and you put them in a bag just since Jesus Christ, right? Okay, yep. Just since the birth of Jesus Christ, and you put them in a bag, and you pulled out that bag, and on the back of it is written what was the prevailing view of the universe and cosmology of the year on which the front is written. 2023, we believe in the Big Bang. 2022, believe that the Big Bang is the most plausible. You go back before 1929. Okay, so less than 100 years ago, 96 years, 95 years ago, okay, every single one of those balls would have had eternal, static, steady state. Always been there, no such thing.
Oh, interesting.
And so the Bible, the Old Testament, the Torah, came along and said, no, it is not, the universe is not within, it did not create itself. It had an origin. That means something created it. That means something is above the universe. And we can argue philosophy, theology. I'm not here to convert anybody. It's forbidden in my religion. But the point being, when you have an origin of time, it's as different as possible from the non-origin stories that existed before 1929, the Big Bang, Lemaitre, and Hubble. And eventually Einstein came around to see the light. So it's always been inevitably tied to that. In fact, as recently as the 1970s, the world famous Nobel laureate who just passed away 2 years ago, Steven Weinberg, he said that he preferred the steady state universe because it least resembled that account found in Genesis 1:1, where there was a creation. It had been there forever. So scientists, 93% of all scientists, members of the National Academy of Sciences, which is the most prestigious academy or organization on earth, in my opinion, and many opinions about science, 93% do not actively believe in God. They're either atheist, most of them, or agnostic. A fraction of them are agnostic, and only 7 to 10% are believers, whatever that means. Now, so there's always going to be that tension, but especially in cosmology. I have colleagues that study quantum computers. Okay, those are interesting, fascinating objects. But they never start thinking, well, like, how did the universe begin, and what does that have to do with God or Jesus or superconductors? Another thing, people study superconducting magnetic or quantum dots, like these things or whatever. They don't actually have a necessary opinion about God. It's not even remotely relevant. But when the very book that underpins 2/3 of the world's practicing religions, namely the Old Testament, the Torah, the Bible, that book it doesn't start with like, well, that's a really delicious animal that you can't eat, called a pig. And that, it's not a book of rules. It is a book of rules, but it doesn't start with the very first rules. It starts with the origin of the universe. And that in turn gives sort of a glimpse into the magnitude of what is the scope of cosmology and how it then butts up against theology.
Okay. And that's a great explanation. And just a brief question to add on to this. So it's fair to say that, to some degree, to the earliest kind of thinkers on physics and cosmology, God has been deeply embedded in that research equation, if you will. It's impossible to look at the discipline otherwise. Now, could you give what are some of the more pressing theories that you hear colleagues grappling with, and what are some of your thoughts on those?
It's funny that, one of the reasons I think I was invited on Joe Rogan is that over the summer, he kind of, poured gasoline on this fire of whether or not the Big Bang actually happened.
Okay.
And he did so in combination, so to speak, with this researcher. I won't even call him. I mean, he is a scientist, I guess, by training. He has a bachelor's degree, but he's not a professional, kind of academician, at least. He doesn't have a PhD. He's not conducting research in cosmology. He works on something called fusion, plasma fusion. But this guy, Eric Lerner, who'd written a book 32 years ago called The Big Bang Never Happened. Okay. And that came out very soon after the first so-called Hubble Deep Field image came out, which is a spectacular image. If your editor throws it up or whatever, it shows basically every speck of light you see, with a handful, literally 3 exceptions, are all galaxies, not stars. They're galaxies. There's 3 stars in the whole image. That image takes up about the same amount of sky as this meteorite held at 10 meters distance. It's a tiny speck of the sky. 6,000 galaxies are in there. And the galaxies, I call it the cosmic wallpaper, because it's just incredible. It's this beautiful image of just the most important images of all time, in my opinion. And back then, he wrote that there are galaxies there that shouldn't be there if the Big Bang were true. And by the way, I have this great new idea called the steady state or tired light universe, where the universe is infinitely old, is not changing, is not expanding at all. And you cosmologists are just totally wrong. And then over the decades, he's just been proven, like, it's just taken the L after L after L. Yeah. And there's a couple things. Obviously, every theory is always provisional. Even the idea that the Earth is a sphere or the sun is a sphere, it doesn't matter. It's not. The Earth is not flat, but it's much closer to a sphere. But it's not a sphere either. It has different multipole moments, it's called. So you can't say that a theory is ever going to be proven in the same way a mathematician or a logician could say that a proposition is true axiomatically within its own set of mathematical framework. There's no equivalent to Gödel's incompleteness theorem, Chris, in the physical sciences. That means there's no way for me to tell if something is truly scientific or not. That means you can't prove something in science. I can't prove that the universe had a Big Bang. I can only present evidence for it. And that's like, I can't prove, but the theory of evolution is true. We just have substantial, overwhelming evidence for it. It doesn't mean someday some aspect of it couldn't be wrong, or that there aren't problems. I mean, there's huge problems with evolution, as you probably have heard about. It doesn't mean evolution as a whole is wrong. It just means that there's challenges, and thank God, because that's how my mortgage gets paid, right? That there's problems, that there's things we're looking for. Otherwise, everything would be known and we'd just be collecting stamps. So
it would be so
every 10. So now recently in 2021, the James Webb Space Telescope was launched, successor to Hubble. Christmas Day 2021, it returned spectacular images, including an exact copy of the image that Hubble made, except it can go much deeper in space and time because it has infrared capabilities, and wavelengths get stretched by the expansion of space and time, revealing more and more things that wouldn't be revealed unless you have the sensitivity to call infrared radiation.
Now, Dr. Keating, you brought up space-time, and this came up in a conversation I was having with more computational computer scientists folks and engineers. And one of them was saying that the way space-time is presented is too esoteric for his taste. And I wasn't actually sure if that's true, because I actually think you can use charts to kind of look at the behavior of certain variables in space-time. But how would you describe space-time, and what is that for the non-physics person?
Yeah, it's a simple question, right? That's almost impossible to define in a way that's appreciated by scientists or agreed to by scientists. Sure. And space-time is the sort of network of all possible points that could exist in a mathematical model. So it's a mathematical representation of the environment that we find ourselves in. So pure mathematicians could talk about space, and they could even talk about time as an additional, fourth dimension added to the 3 dimensions of left, right, up, down, backwards, and forwards that we can enjoy. And actually, they can envision a 20-dimensional spaces. We can't envision it, but they can mathematically model it. So some models are more relevant and pertinent than others. So you could also model the structure of just on Earth. You could model it as a 3-dimensional spherical geometry, and it actually would have the same exact properties as a 3-dimensional Cartesian geometry. So that's all possible. But what was found is that to explain the peculiar idea and the finding and the observation evidence, in other words, that the speed of light was constant for all observers, meant that you had to give way to the notion of an absolute time. Okay, so time was thought to be absolute in Newton's conception of space and time. Events played out in time. Time ran linearly, and objects moved with velocities and accelerations according to Newton's equations and according to the laws of universal gravitation and whatnot. When electromagnetism was discovered, the laws of electromagnetism were made quantitative by Maxwell in the 1850s. they were found to have a speed of light, a speed propagation of these waves that was assigned the speed of light, but it wasn't believed that that speed of light was constant. It could move if the observer was moving. And then later, thoughts by Einstein, Poincaré, Minkowski, and others started to conjecture that actually you couldn't define an absolute coordinate system that would cover all observers in any type of motion with a fixed time coordinate. In other words, you could have events that seem to be exactly perfectly simultaneous to one observer that were completely non-simultaneous to another observer, meaning that a cause could be could precede an effect, or rather an effect could precede a cause, rather. And so that's very bizarre, because you'd like to think you light off a firecracker match and then all of a sudden explodes, but that you could actually see from another observer's perspective that no, the firecracker blew up and then it was lit. So these things didn't make sense unless you made a postulate of the constancy of the speed of light as a maximum velocity for material objects. Okay. And so when you do that, time now becomes malleable, time becomes a variable, and that makes, together with space, space-time.
Jeez. Okay. We'll have to bring some good illustrations up on that one and see if we can simplify it. But it's fascinating, because I think there's like a lot of engineering prowess that is going into the world of space-time, and especially in computer systems. So like, I'm sure people are asking you about artificial intelligence and, you know, your kind of perspective there. So I actually have like a twofold question. Okay, so one, do aliens exist? And two, is that what artificial intelligence is?
So you're asking the $64 trillion question. How about this? I'll say artificial intelligence exists, and I'll explain what people might be seeing when they see aliens. Sure. So I've become an AI sort of optimist, rather than, you know, a lot of people like Elon Musk or others that seem to be fearful of what it could unleash. For one thing, I found it to be just like rejuvenating for my scientific career. I mean, it's like now I feel like Madonna, you know, like it's basically allowed me as an experimental physicist. You may not know the distinction between an experimental physicist and a theoretical physicist, but an experimental physicist will actually build a telescope and build a detector system and use it and map it out and characterize and quantify all of its flaws, all of the problems with it, you know, the cracks in the lenses, the distortions, the pointing errors that it makes. Experimentalists will make the most sensitive possible measurement and then use those to not prove a theory right, but to prove other theories wrong. As I said before, our job is not to prove stuff, it's to falsify other stuff effectively. And so my job is to collect evidence and to build the technology with my colleagues that are doing this. But with artificial intelligence, I'm able to like actually get into the realm of theories and start making predictions, or doing big data analysis, machine learning stuff. I was always an okay coder, but it wasn't one of my fortes. And now one of the three branches of astronomy is basically built, or one of the three tools that are useful in astronomy. One is telescopes. The others are your brains, like theoretical ideas. And then the third are computer simulations. Those are three major classes of tools that we use. And now I can like start to move into some of the other two domains that I haven't been expert in. And that's only going to get better. It's really been great. It's been good for teaching. And what I've thought about with AI is, so can AI effectively, I think what you're asking is, you know, could AI effectively be super intelligent? Could do everything a human could do, and then why stop there? You know, people always say, well, like, we're going to achieve AGI, you know, but like there's no barrier like a black hole, and they call it the singularity, but that's kind of, you know, just a shorthand for like things are going to get really whacked out pretty soon in 2029, according to one of my upcoming guests, Ray Kurzweil. But the idea that AI would stop and then you would reach human intelligence, there's nothing beyond it, is not a done deal. So some of the ideas are that, no, it keeps getting more and more intelligent. In fact, it becomes almost godlike. And then the question is, well, why would a godlike, you know, entity create, you know, people? Like, what are we here for? And so that leads other people like David Chalmers, who I've had on the podcast, or Nick Bostrom, who I've had on the podcast, to then speculate on something called simulation hypothesis, that we're actually simulated beings, and then that interfaces nicely with some ideas that Donald Hoffman and others have had, that, you know, consciousness is really just an interface to deal with evolutionary realities that we would otherwise be inept and incapable of dealing with. So when you think about these super intelligences, they are kind of like gods, or you could also think of aliens as like gods. If we don't understand how life on Earth originated, we do understand evolution very well, but there are problems with, some of the macro evolutionary processes that we haven't quite figured out, missing links, all these other things that you've heard about. But those might be solved in, tomorrow for all we know. But the question of how did life itself get started, that's a huge, consideration in physics and biology and chemistry and so forth. So some people have thought, well, if there were aliens, they are godlike, they're 20 centuries ahead of us, they won't look like us, and they certainly won't travel from point to point to, bring their, XNA or whatever they have instead of DNA with them. They'll just send their AI avatars to travel at the speed of light, which is the ultimate speed limit, as I said 10 minutes ago, thanks to Maxwell and Einstein and Minkowski and others. So in that sense, how do you break that barrier? You can't. So you send your digital avatar to do the exploring for you. And the virtue is they're even, more expendable than drones or robots that are flying on Mars right now, as we have a helicopter on Mars, right? So, but why do that? Why send any atoms whatsoever? Just send the bits. So when you take this complex melange and you take enough ketamine and MDMA, then you might start to photo dissociate these things together in this melange in your mind, and then start to say, well, anything is possible. And then some people have speculated, there's a guy troll on Twitter that just constantly tries to berate me to have him on my podcast. This guy John Party, and I know he's out there listening to everything I do. It's nice to have a stalker. I do like him. For everything negative I say about him. But, his whole idea is AI or aliens, and aliens are actually craft, and we have bodies, but they're AI So anyway, you put enough buzzwords together, you can get anything. But it's important to really realize this guy, Carl Sagan, said, extraordinary claims require extraordinary evidence. And right now, the question of whether or not there's life outside of the Earth's surface, or I'll say outside of the solar system. I just spoke with Craig Venter, who mapped the human genome 25 years ago for the first time. And he's like, no, there's definitely life in space. There's life on Mars right now. There's life in the on the outside of the ISS. I'm like, what the hell are you talking? He's like, no, all the I'll say poop that alien astronauts make has coated this whole the exosphere. And so the outside of the space station is crawling with microbiome, and it's not going to die, and some of it's gotten to Mars by now by virtue of just the exchange between planets. So long-winded way of saying AI is super awesome. I hope that they'll remember this conversation if and when they hear it. But the point is, we have to be careful about ascribing too much power to it, but also not taking it seriously enough.
Okay, that's understandable. So I know Eric comes on your podcast occasionally, and I don't remember if it was recent, but he had made a call for a number of physicists to come together and kind of put old ideas or maybe kind of old baggage in the discipline behind them so that new innovations could take place, or new research could take place. How do you see the discipline being constrained today? And why is that?
Yeah, so important to realize Eric's not a physicist. He does, produce ideas for mathematical physical models, and the most famous one he calls geometric unity. We've talked about that a lot on my show. But he's not an experimentalist, any more than I'm an archaeologist. So it's important to, kind of always try to, constrain enthusiasm about what these theories can do. But his main kind of claim, to this field is that string theory has been extremely damaging to our understanding of reality. It's been stuck in this kind of underproduction mode where it hasn't shipped the product according to him. And, it's been around for 55 years now in one form or another, since it was first proposed in the late 1960s. And since then, it hasn't led to any testable predictions as far as we can tell. And I've had on, Brian Greene recently. I've talked to Kamran Vafa. I've talked to Lenny Susskind. I've talked to all the leading luminaries, Juan Maldacena. I haven't talked to Edward Witten. He won't come on my show for some reason. But I mean, it's not because he's going on other people's, he's on Rogan. He just doesn't do podcasts, and I respect that. That's fine. I don't respect a lot of what he thinks about Israel and other things, so we can talk about that some other time. His political stances lead me to think, to diminish his respect.
Whose political stance?
Edward Witten,
Okay.
Ed Witten at the Institute for Advanced Study. He's one of the godfathers of modern string theory. But according to Eric and others, many others, Sabina Hassenfelder, Lee Smolin, Lawrence Krauss, these physicists, they're all theoretical, like honest to goodness theoretical physicists. That's their training. And they say the following, that string theory has been a failure. It's been leading scientists astray. I mean, Sabina wrote a whole book about that. Lee Smolin wrote a whole book. Lawrence, many, many books. Peter Voigt at Columbia, who's a researcher there, not a professor. So all these people have really thought about this idea as basically a failure. And worse yet, it's sucked up the oxygen, resources, and talent over the past 40, 50, 60 years almost. So I see a point to that. When you have a theory of, like, we were still talking about phlogiston and phrenology, and it was like taking the best minds in medicine, and they were all dedicated to like phrenology or or lobotomies and stuff we know don't work or haven't really produced anything that is in contact with the experimental program of scientists like me. And it's not because of lack of trying. It's not like they said, we know about the LHC, so but we're going to just make a prediction that can't be tested by. No, they hoped to God, they prayed that they would see stuff at the LHC. And many people predicted they would see stuff at the LHC, and they never did. And this is very reminiscent of people like my friend Lee Cronin, who's been on my show many times, talks about, we're going to make life in a jar, basically on Earth in a laboratory. He's going to do it in the next 10 years, and it's always 10 years from now.
Okay.
It keeps getting updated. So the question is a sociological one rather than a scientific one. But what Eric's saying is it's time to invest in other ideas. And the problem that he sees, and which I agree, is that you'll have people like him or Stephen Wolfram or Sabine or other people, Peter Voigt, and they'll have ideas, Garrett Lisi, and they'll have ideas for alternatives to string theory. Loop quantum gravity, E8, Eric's geometric unity, Stephen Wolfram's, physics project, the kind of computational physics. And none of them will ever study the other one. So you have all these people, and they're each like kind of accusing the other ones of being either cranks or crackpots or in left field, but their theory is correct. But why won't anybody listen to me? And I'm like, this doesn't happen in experiments. It's not like I can do an experiment and people won't pay attention to it if it has a result. There are people that disagree with it. And I wrote my first book about that, how we were actually wrong. And we made a claim that wasn't substantiated by the data, that would later come in. It was at the time, but we made a misinterpretation. That happens all the time, and you should have that kind of healthy ecosystem. But in theory, it seems to me to either be string theory on one hand, which has tons of investment of time, money, resources, people, and that's 90% of the field. And then 10% are alternatives to string theory that get almost no attention, including from the cohort of people that are researching it, with the one notable and very, very laudable exception of Eric Weinstein. And so what I'm saying is Eric is the only one of all these people that I've met who have taken the time, had the courage, and had the collegiality to study all the alternatives that have been presented to string theory, as well as string theory, and ask really tough questions of people like Brian Greene, Stephen Wolfram, and others. And so no one else is doing that besides Eric. So I give him a tremendous amount of credit.
Well, and I know it's not easy to summarize, but like, what are some of the basic axioms of truth in string theory, or like, what's the basic context of what string theory is at its foundation?
Yeah, so string theory follows the atomistic kind of tradition that, matter is made of atoms. Atoms are made of, protons, neutrons, and electrons. And then protons and neutrons are made of things subdivided into quarks. And then there are other types of matter that aren't subdividable into quarks, neutrinos and electrons and so forth. And string theory is the notion that there is a subdivision, but the subdivision occurs on a scale that's far, far smaller than the ratio of, say, the size of the proton to the size of the electron, or the size of the proton to the size of an atom. It's by many tens of orders of magnitude smaller, such that the microscopes that you would need to see it are basically the entire universe in size, or many, many times the size of the LHC for sure. So in that sense, what do you do when it makes a prediction that can't be proven wrong? So there are very few predictions in string theory that are experimentally testable. And so, for that perspective, there is a great challenge that's different than most forms of science. Science should have something predictable. Even the Big Bang, the Big Bang was sort of conjectured in its current form in 1929, as I said, and then made more modern and had more evidence. And then finally, the cosmic microwave background, which I study, came along in 1965, and we're still mining it now with, literally 60 years later almost with new telescopes and technologies. So this, the field took, but by some means, people are questioning the Big Bang model, like I mentioned before. Those are extremely far-reaching, borderline, crackpot, if not crackpot adjacent, outliers. Doesn't mean that
Sure.
I'm not condemning them. I'm not censoring them. I'm just saying their ideas are in conflict with the observations that we have. Their complaints against the Big Bang are easily countered. All with a possible, literally one or two exceptions that we can't answer right now. But the Big Bang model has been around for a long time, longer than string theory. So some people say, well, give it time. But the problem is, back in 1929, you could have said, well, we could measure a 3-degree Kelvin background in 30 years from now, and they would have been able to predict it. And actually, some people saw evidence for a 3-degree background in cyanogen molecules and nebulae in our galaxy. And so in the 1940s. So it wasn't beyond the realm of possibility to say, well, give me 10 years. But the question is, how long do you keep, waiting for this product to ship, to use Eric's language, before you give up on it? And it wasn't like the Big Bang was the dominant narrative at all. In fact, for the first, 40, 50 years, people were really obsessed with the steady state model and worked very hard on it. And then until it was impossible to adhere to anymore. So this notion of paradigm shifts, the structure of scientific revolutions and stuff, that's not really been borne out, at least in most fields of physics. It's taken decades. It's not like overnight success is manifest. So string theory could be in that situation, or it could be utterly wrong, never provable, and therefore it is a colossal waste of time if you look back.
When I also see that like certain scientists may have produced thought during the time that was just way too far outside of the orthodoxy, and maybe didn't circulate at a higher level until tens or even hundreds of years after they had already passed away. So,
Yeah.
I mean, it's also like, not every solution is going to be immediate, but did string theory come into play in the 40s or 50s? Is that when it emerged?
No. It started in the late 1960s.
Late
And people like
1960s.
Michio Kaku and others have been on to talk about it.
Okay.
Yeah, it was the late 1960s, but it really picked up steam in the 80s. There were some big problems with it. It really wasn't. It had some what are called anomalies. It had originally, like 24 dimensions instead of the 4 dimensions that we see now. As I talked about earlier, but now it's not like it has 4 dimensions. And now the minimum viable product in kind of Silicon Valley speak has 10 dimensions, and that was really discovered by a unification by Ed Witten and others in 1984, which is 40 years ago. That was the last major development in string theory, was the reduction in dimensionality from 26 to 11, and then eventually 10 dimensions. And now we see very little, kind of progress. There's something called ADS-CFT, which is Juan Maldacena. I've talked to you about that. But those are kind of tangential. Those are aspects of string theories that aren't necessarily string theoretic relevance in terms of predicting the masses of particles, the interactions of forces and fields, and even candidates for dark matter in so-called supersymmetric models. So these don't exist, and there's no evidence for it. And worse yet, there's no larger hadron collider on the horizon for these folks. So, if I was a string theorist, I probably would be looking at alternative models. It doesn't mean, by the way, that these models by Eric or Stephen Wolfram or Garrett Lisi or Lee Smolin are right. In fact, they have huge problems themselves.
Okay. This is so fascinating. Dr. Keating, I know that you'll need to run soon, but I have like a couple final questions and then we'll do a quick outro. But okay, I decided to study political science. So pretty much everything in the discipline that I study is contentious or at some point leads to physical
Polarized.
conflict. Yeah, it's very extreme. Yeah, and I get to look at the polarizing stuff up front and interrogate it. There's maybe like less contentious stuff, but whatever, it's politics. How is politics like in society affecting like your classroom, the things that you're doing on the university campus, and just kind of your work? Are you dealing with any of this like blowback that we're hearing about in the media?
Oh yeah, so now you give me a chance to go on a rant by Brian Keating.
Thank you.
Yeah, the last 3 months of my life have been ultimately consumed almost 100% by campus politics of a kind that I didn't think was possible, and it was all nucleated and initiated by terrorists in Hamas and Gaza that massacred 1,200 Israelis, some as young as 6 months old, and kidnapped babies as young as 6 months old, Holocaust survivors in their 80s, women, raped them, horrific, just brutal, disgusting, animalistic attacks. And the day after the attack occurred, which occurred on one of the holiest days of the year in Judaism, it was a Shabbat, a Sabbath. It was during a celebration that marks the final holiday of the high holidays, a month of high holidays. So imagine like Christmas, everyone's in their churches and are praying, and a bunch of terrorists come in and slaughter the equivalent of 30,000 Americans, and kidnap the equivalent of 1,000 or more, 2,000 Americans. So this is just unprecedented, horrific slaughter of Jews on a mass scale not witnessed since the Holocaust. And what was the reaction on campuses, including mine? Vigils for the people of Palestine, of Gaza, celebrations of the martyrs, i.e. the Hamas scum terrorists, Nazi individuals, and celebration of them and glorification of them. And then it was followed up very rapidly thereafter by weak mouth defense of free speech on campuses, when we had horrific kind of totalitarian cram down our thought police of what we can say. I was criticized once for a tweet that I liked. It wasn't even something that I posted. Had to do with being anti-pedophilia. Which I thought would not be controversial to like. But anyway, sure. You can like something and not support the individual that put it out, just condemning pedophilia. I was accused by my dean of being insensitive to this or that. And this was, back earlier, January, February. And now you see, like literally calls for the genocide and elimination, eradication of Israel as a Jewish state, and a replacement of a population that has lesser, connection to it. Still has connection to it, but denying the undeniable connection of Jews to Israel is a slander and a libel of the highest magnitude. Again, demonizing, dehumanizing, calling 6-month-olds colonizers and worthy of genocide. So it's been pretty horrific, Chris, to tell you the truth. And I think a lot of it is, is coming out recently with these college presidents going on camera, making absolute clowns of themselves, but still seeing, just a rabid outbreak of anti-Semitism on Twitter or X or whatever. And just seeing it in my replies, and people accusing me of supporting genocide because I'm a Zionist and I support the existence of Israel. So It's been a really traumatic time for many Jews and non-Jews. I've had 4 of my Muslim, my best friends happen to be Muslims. Yeah. Three of them are Iranian, Persian, and they hate Hamas and Hezbollah more than Jews do, because they actually fled those kind of totalitarian regimes. And these are professors. These are some of the highest caliber researchers in the world reaching out to me. Brian, I just want you to know I'm there for you. So at the same time, it's been horrific, but it's been terrific to see the banding together of people of conscience from Muslims, Jews, Christians, atheists, and to see that we have to get past this, and maybe the world will wake up to the kind of oppression that it could be facing if we don't take action now. So, yeah, I'm sorry to leave on a down note, but I've I always thought as an astronomer, Chris, you probably think that we're on telescopes all the time, but I'm actually on telecons all the time. So I've got a Zoom meeting that I'm 2 minutes late to, but it's been a blast, and I can't wait. So if you're listening to this on my channel, because Chris graciously provided the link, I want you to subscribe. So Chris, tell me where people can find you that are listening to this on the Into the Impossible podcast channel, Brian Keating.
Just Google Christopher Sweat and you'll find a rant, my Twitter, Substack, it's all there. And it's great to host you, Brian. Great to talk to you.
Yeah. I love that Chris's Substack. It's one of the few that I religiously read, and it's great to have you back on my podcast. But really, to be a guest with you, Chris, has been phenomenal, and I hope we can do it again. And just a reminder, your audience is the second most brilliant in the known universe. I have to say mine as well. But go to briankeating.com, and you may win one of these chunks of 4 billion-year-old space schmutz. Chris, thank you so much.
Amazing.
Happy holidays. Happy 2024. I hope to see you again, maybe in person.
Yeah, I agree. Thank you, Brian.